Good morning, welcome, and thanks for joining us for today's HIS Talk webinar, Healthcare Organizations, Making the Most Out of Azure DevOps, brought to you by Citius Tech. I'm Lori from HIS Talk, and I'll be moderating. We have two speakers today. First up will be Harshal Sawant. Harshal is a solutions architect at Citius Tech. Joining him will be Somayan Soman. Somayan is a cloud solution architect and part of the Microsoft One commercial partner technical team at Microsoft. And with that, I'll turn it over to you, Harshal.
Thank you, Laura. Good morning, folks. I'm Harshal Sawant. I have 13 years of product engineering experience, of which 9 years has been in healthcare product engineering for some of the largest names in healthcare, spanning across medical imaging, patient portals, personal health records, and digital transformation. I'm currently leading DevOps and mobile practice in Citius Tech, and I'm very excited to share my experience of DevOps transformation in today's webinar. I have with me Soumyan Soman from Microsoft, and I'll pass on to him for introduce. Soumyan, over to you.
Sure. Thank you, Harshal. Thank you, everyone, for joining this session with us today. My name is Soumyan. I'm a cloud solution architect at Microsoft. And I've been working with Microsoft more than 11 years, primarily part of our Microsoft Services division. And throughout my experience, working with our direct partners and customers, helping them throughout their journey to the digital transformation using Azure platform. So at this point, I'm specialized in the application modernization and cloud native technologies. So throughout my engagement with my partners and customers, I'm helping them leveraging this kind of technologies to help them to modernize their solutions into the cloud using Azure. So that's all about me. Back to Harshal.
Thanks, Soumyan. So in this webinar, we'll talk about key pointers for starting DevOps and phases of DevOps evolution. Then we'll talk about Azure DevOps and how the offerings of Azure DevOps can be mapped to each of these phases of DevOps evolution. Key learnings from this webinar will be understanding DevOps 2018 stats, trends, approaches for starting and DevOps evolution, understanding Azure DevOps offering and how they can support organizations' DevOps evolution. With this, we'll start with our first section, which is DevOps 2018 stats and trends. When we look at 2018 figures, there are a few interesting findings which become apparent. First, DevOps is growing. Many organizations have started implementing DevOps in some or other form. And hence, as per Forrester, 2018 is the year for enterprise DevOps. Second, CIOs and senior leaderships have now started understanding the importance of DevOps transformation. And this is because of the imminent threat of being outclassed by competition, which has started using DevOps for providing faster and stable releases of feature sets to customers. Third, majority of organizations are facing challenges in scaling DevOps company-wide. And which is why you can see 30% of enterprises are able to implement DevOps. Only 30% of enterprises are able to implement DevOps at a company level. Fourth, executives. Okay, so 64% of CIOs feel that the security teams involved in technology design and development, as against 39% of team members feel about that. With this, we'll quickly go into the next section, which is starting DevOps. This section is intended for organizations who need help in defining DevOps roadmap, and for organizations which may have started the DevOps journey but want to validate their approach. So cultural norms and technology practices required for improving quality and flow at every step, from a business idea all the way to the working code, differs from organization to organization. Hence, the definition of DevOps roadmap would change from organization to organization, and it should be based on a set of inefficiencies and wastages which have in their development cycle. In this slide, we are listing 3 stages via which organizations can define their DevOps roadmap. First, identifying inefficiencies. This is one of the most challenging stage, as most of the organizations are unaware of their inefficiencies and issues when they're doing, say, a monthly release. In subsequent slide, we'll talk about the proven approach for identifying such inefficiencies. 2. Prioritizing outcomes. Main objective of this stage is to achieve organizational alignment on DevOps backlog and implement those. And the third one is the validating success. Validate your success using industry-based DevOps metrics. In the next slide, we'll talk about an approach which has worked well for CTS Tech and is defined by industry thought leader Jez Humble for identifying inefficiencies. This slide talks about identifying inefficiencies via deployment pipeline. Deployment pipeline is the process of moving from a business all the way to development. Here we have mapped few metrics with actors and phases of deployment pipeline. Metrics like percentage of requirements reworked, percentage of delivered features at business idea or requirement stage will help you gauge product owners who are writing requirements and are not understood by developers or probably not used by the end users. Whether the product will help you understand whether the product owners are spending time prioritizing or deprioritizing features that were never getting developed, or are they wasting time providing sign-off on features in test environment where the code is not correctly deployed or environment is unstable. Similarly, development metrics like percentage of time environments need fixing before acceptance, or percentage of defects associated with code versus environment would help you understand whether the developers are wasting time implementing new features that do not meet the business expectations. Wasting time triaging defects which are not related to the code but were environment related. Or are they debugging and fixing same defects because of which the fixes are not committed to different branches? Moving on to the testing phase. Then we move to the next phase, which is testing phase, where the metrics like time taken to execute full set of testing, repeatability of testing, percentage of defects found with unit testing. These set of metrics help you understand whether the QA team is wasting time testing what was wrong version of code on an environment, which has not been correctly configured. Or is the QA team spending time testing the code and finding out defects on two different branches of code? Finally, we move to release and operations phase, where metrics like time and effort required to deploy and release to production, number of issues found during release, time to restore service will help you answer for queries like release team wasting time to find out right version of code and proper definition of environments. Instances where developer team are not communicating changes that they are making or not providing instrumentation on code. In a nutshell, what has worked is creating, documenting, automating, and optimizing deployment pipeline is a key to identify and improve efficiencies and effectiveness. With this understanding, we'll now move to the next stage of starting DevOps, which is prioritize outcomes and validate success. Prioritize outcomes. Once the inefficiencies are identified, next hurdle is to create an organizational alignment on the biggest source of wastage. And this is where the role of executives, which is the prime audience here, become important. DevOps implementation should be executive-led approach rather than executive-driven approach. Defining objectives based on monthly iterations. Avoid taking any big bang approach. Divide your backlog into monthly iterations. Identify impediments which are blocking any improvements. These impediments should be prioritized in the next iteration. The next step is validating the success. So validation of DevOps implementation should be on 2 parameters, which is velocity. Why velocity? Because DevOps is all about speed and velocity. Few of the metrics which come under velocity are frequency of deployment, speed of deployment, speed of build verification, etc. Next is quality. which helps make sure that we are not compromising on quality because of speed. Key metrics include deployment success rate, incident defect rate, etc. Next one is productivity, which helps measure whether the velocity and quality are helping deliver productive outcomes. Key metrics here are mean time to restore, features usage, etc. And last is security, which helps measure vulnerabilities introduced while delivering software changes. Key metrics here include security test rate, code scanning rate, defects, etc. With this, we'll move to the next section. Understanding. Now let's move to the next section, which talks about the phases of DevOps evolution. At the start of the webinar, we found that majority of organizations have started the DevOps journey, but unable to scale it at a company level. Hence, in this slide, we have quantified the DevOps journey, identified stages of evolution, and key practices that help organizations in the journey. For organizations starting DevOps journey, these stages will help achieve success faster. And if they are in the middle of the journey and feeling stuck, then it will help you get back on track and scale your success. DevOps evolution starts from normalizing tech stack, then standardization and reduce variance, expanding DevOps practice, automating infrastructure, and finally, highly evolved organizations have started providing self-service functionality. Typically, people associated with DevOps associate DevOps with automation and jump directly to the step number 4, which is listed here. However, infrastructure automation appears late in the overall evolutionary journey, as it is enabled by things that characterized earlier stages. We'll be going into detail of each of these stages in the subsequent slides. However, what is enabling this transformation is a set of foundational practices. Foundational practices like teams configuring, monitoring, and alerting configurations, reusability of deployment and testing patterns, configuration management using configuration management tools, as well as teams contributing to toolings. All these tools are not a one and done stage in a linear DevOps progression. They need to be maintained and enhanced throughout the organization DevOps evolution. Now we'll look into each of these DevOps evolution phases. What are the key practices which define them and benefits? So the first is normalizing tech stack. Earliest efforts towards DevOps transformation should be centered around reducing the complexity. Couple of defining practices which help in normalizing tech stack is leveraging version control and standardizing operating set. Separate data from code. Many teams initially combine their application configuration data with their application code. It is a standard practice to separate code from data because some of the configuration data varies with deployments. For instance, take into consideration the dev, test, productions, etc. While the application code remains the same. Sensitive data safeguarded from exposure. Here, teams can leverage services like Key Vault or Zookeeper to safeguard sensitive information. Source code available to other teams. Opening up version control is an early driver because it encourages collaboration via contribution from other teams. It is likely that there are pockets of success around organization, and reusing what other teams have already built accelerates development of capabilities, enabling success to scale. The next practice here is standardizing set of operating systems. Get rid of outliers or snowflakes that need to be maintained, tested, and managed as one-offs. In organization, it is not uncommon to have multiple applications running multiple operating systems. For example, one application running on Windows 2012, another running on Windows 2012 R2, and yet another on 2016. Eliminating even one of these variables significantly reduces complexity. Key benefits derived from this stage would be reducing complexity and license cost, ability to hire for specific skill set, shared knowledge across teams. Next, we'll move into the next stage, which is standardize and reduce variance phase. Every organization has a variance, which can stem from several different causes, like older technologies which are not migrated, homegrown products that don't follow industry standards and lack common interfaces, proliferation of tools that have overlap and haven't been rationalized, mergers, acquisitions. In this phase, organizations should work further on standardizing and reducing variability. So, couple of key practices which come up in this phase is standard set of technologies. Standardization of technologies increases velocity, as delivery team no longer have to continually relearn how different technologies operate, scale, fail, recover, and upgrade as well. The next practice here is deployment of single operating systems. Now, operating system standardization seems straightforward, but it is challenging, especially if teams are supporting legacy applications, which run on specific operating systems. Common path here is to eliminate any stray operating system. If there are 5 operating systems, reduce them to 2. Next, make sure that they are using the same patches, same update levels, same BIOS and firmware, if applicable. With this normalization, teams would have more time and attention available for further improvements. Organization can move faster when a single operating system or a small set of operating system is standard. This reduces time required for patching, tuning, upgrading, troubleshooting across multiple operating systems. Key benefits from this stages are faster delivery velocity, development staff working on multiple applications, systems, or components, reduced surface area for vulnerabilities, and fewer moving parts to maintain, upgrade, and load. With that, we'll move to the next phase, which is expanding DevOps practice. While phase 1 and phase 2 were reduce the overall complexity, the objective of this phase is about scaling DevOps across an organization by sharing improved tools, applications, and knowledge with other functional areas of the business. Key practices in this phase are reusability of deployment patterns and empowering teams by updating processes. Let's look into reusability of deployment patterns. Here, organizations may plan to use the same tools for deployments. All deployments run through continuous integration, CI. In organizations where deployment patterns are truly mastered, multiple applications use the same pipelines and jobs for deployment. Only the application name and possibly a few other parameters are fed to the job as configuration. With deployment standardizations and reuse to this degree, any optimizations to the deployment pipeline is immediately consumed by all applications, so the benefits multiply quickly in this case. The next practice is empowering teams by updating process, reducing bureaucratic red tapes and wait times. Working to accomplish changes and deployments without wait time isn't about trying to bypass organizational process. It is about revisiting why processes exist so that they can be simplified, normalized, and optimized. When processes are simpler and consistent, they are easier to automate, which comes in handy as organization progresses towards self-service. Performing service changes during business hours. Few organizations do maintenance only during business hours, making use of deployment strategies like canary deployments, blue-green deployments, or active-passive sides of an application. These architectures and deployment patterns, optimized for rolling changes through the system, often allow for a relatively easy backup plan if things go wrong. Last point here is post-incident reviews and sharing of results. Post-incident reviews are a blameless look back at what happened during an incident, how it happened, what improvements could be made to shorten the duration of incident, improve the understanding of systems behind the incident, prevent it from happening again. Key benefits from this phase are optimizations to deployment pipelines patterns are immediately consumed by all applications. With that, we'll move to the next phase of evolution, which is automated infrastructure. Successes in earlier stages result in easier implementation of automating infrastructure delivery. Key practices in this phase is automated system configuration and provisioning. System configurations are version auditable and contains history. This allows reusability as well as systems that make change application deployments operate in an environment are pretty critical in the overall process. Ability to repeatedly deal with account creations, removal, load balances, configuration changes, security changes, monitoring policy updates allow organizations to automate infrastructure that lags behind the business. And the obvious benefits for these phases are increase in deployment speed, consistency across environments, document behavior, and portability. One important consideration which I would like to highlight here is plan to automate infrastructure items which run with highest frequency across widest swath of infrastructure components. This would help you get the highest ROI for the infrastructure, the automated infrastructure work which we do. Turning now to the last phase of DevOps evolution. This is where the highly evolved organizations are currently placed, are using it. Fully automated incident response is a daunting task. Hence, start small by automating response to specific type of incident that crosses functional boundaries. Automated incident response are beneficial as manual responses when dealing with intrusion, malware, etc. can be expensive. Focus on processes that identify issues as well as deploy when responding. Bringing security team into development lifecycle early and start collaborating automated response to one specific incident across functional boundaries. With this understanding of DevOps evolution, we'll now move to our next phase, next section, which is Introduction to DevOps, Azure DevOps, and explore how Azure DevOps support organizations in their DevOps journey. I'll hand over to Soumyan to walk us through the Azure DevOps slides. Soumyan, over to you.
Sure. Thank you, Harshal. All right. Do I have the access to the presentation?
Yeah. Yeah.
Okay. All right. All right. Let me see. Okay. Thank you, Harshal. All right. So far we have seen an overview of DevOps and how does a DevOps evolution look like, and then now this particular section we are going to see from what kind of technology or tools that we can use to support your DevOps journey successful. So if you look at a typical development project, it's always start with an idea. It could be an idea coming from an individual or a group of individual, and then to make that idea to happen, that idea could be building a solution or building a product. It's always started with a planning phase. So in the planning phase, they will come up with a team, and in that team, they will be assigning set of responsibilities. So that key stakeholders might be a developer, testers, project managers, etc. And then always a product development is typically done by a development and infrastructure team. So the team who is owning that particular task, they will be assigned to a specific task or work items we call to achieve a specific set of features to be implemented on a specific life cycle. So that is a planning and tracking. So that is a first phase of any type of a product or a solution development. That is the stage we start. And then we will take one example of, like, let's say I want to build a specific feature for a solution, and then we already planned about that, and we already defined all the key stakeholders who need to work on that. And then it is going to the development team. So development team are the ones will be choosing a specific programming language or technology, and they will be developing or implementing the specific feature, and they will be running the unit test cases to making sure that the specific feature is working as expected as per the use case that we have defined in the planning phase. And then once everything looks good, then it will be deployed into a specific environment that can be tested, and then if everything goes well, it can move into a production environment. And once it goes to the production environment, the journey of that solution or a product is not ending there. So we need to constantly monitor the solution for performance issues or any end user feedback, so that you can constantly make the changes immediately, and you can make this particular process continue. So again, so based on all the feedback or any issues that we have found, again, it is going back to the planning and tracking phase. And then the development team is taking that specific feedback, and they will be implementing that feature, and then it is going to the release cycle and again deployed into the production. So this particular life cycle is commonly called as a DevOps life cycle of a specific product or a solution. So DevOps itself, it's a union of product, people, and process to enable the continuous delivery of the value to our end users. So I want to emphasize that particular part of the continuous delivery of the end value. So here, I'm not talking about a software or a product. So an end value means it could be a simple improvement about your process can improve the value of how we are delivering this particular service or a product to your end users. And this end users, again, it is something very opinionated. It may not be your developers or QA team or anyone who is building that solution. It could be your customer, or it could be your employees within the company. So DevOps, it's not like Harshal explained earlier. It's not really a product that you can install. It's all about a union of all these different stakeholders, people, process, and products to enable the continuous value. So, and if you are looking at more of like a technology or a solution or a product centric, then this would be the typical life cycle look like from a DevOps perspective. So if we look at the different set of tools available today for all of these particular stages that we have seen in the previous slide, these are the different types of tools companies are using today. For example, for planning and tracking, you can use Jira or Rally. And for development, there are so many different types of IDE or integrated development environment and tools available. And for release management, there are many other tools available like Chef, Puppet, and etc. And for monitoring, it has its own tools. So you can see that the Azure DevOps is not something like a completely new platform that you need to use for accomplishing your DevOps lifecycle. You can see that it's a kind of a center of access. You can use our tool is called Azure DevOps. It's a fully managed service. We'll go through that in the next coming slides. But this is a central tool that you can use for accomplishing your DevOps lifecycle with the help of different tools available and integration service available on top of that. You can stay with whatever tools that you are using today. For example, all of these different phases that you can see that we have seen that customers already using this kind of tools. So, but if you want to go with that more of like the velocity, constant faster iteration model, then if you want to use certain tools, then we are providing this tool for making that life cycle easy. And also it will make this particular union concept of union of people, product, and process in a single place. So you all can collaborate each other, the project managers, developers, testers, and even the infrastructure team. You all will be working towards a common goal, which is building this solution and delivering the value to your end users. So Azure DevOps is a fully managed service available from Azure, and it has capability to integrate with all of this different life cycle of your project. And also it is an open platform, so you can integrate with whatever tools that you can see in this list, or you can also bring your own tools as well. So here are the key pillars of Azure DevOps service, starting with Azure Boards. So Azure Board is a fully integrated platform for gathering the requirements, managing the work items, managing the task, and review the life cycle of your project, making sure that it is going perfectly and it can meet the particular timeline what you have in your planning phase. So Azure Boards you can also use for like sprint meetings and stuff. We'll go through that individually in later slides. And it's an end-to-end solution for organizations looking for an enterprise-grade toolchain. And this particular service you can use regardless of your journey on your DevOps lifecycle. So Harshal mentioned about the evolution to that scaled model in an enterprise. You can use Azure DevOps, even the team member is like less than 10 people versus and their team is more than 100. So regardless of the size of your organization, you can start using the Azure DevOps service tool to leverage that particular functionality that we all are talking about here. And Azure Repos is nothing but a source code repository. It supports both the Git and the Team Foundation version control protocol. And one of the key differentiation between other services are you will be getting unlimited number of private repos. So you don't need to share your source code, and it will be available only for the private team, and it is authenticated and authorized by Azure Active Directory. And pipelines are another key component of Azure DevOps service that is primarily built for creating your continuous integration pipeline and your continuous deployment pipeline. We'll go through that again in the next slides. And Azure Test Plan is for managing all of your test cases, load testing, and even generating the reports regarding the test that created based out of your test plans that you have. And Azure Artifacts, as the name stands, it's an artifacts location for NuGet, NPM, Maven packages, and you can use that one for your CI/CD pipeline in Azure Pipeline. So again, this is a platform. You can see that again, if you go back to the previous slide about different life cycle of your DevOps, you can use a single tool for managing the entire pipeline, and you can even integrate whatever tools that you are using today. And it is scalable to any team or any project size. We have different plans available. You can start with a free version, and you can go with more of like a paid version, which it will be looking for the number of users going to be leveraging this particular platform. So this platform, even though it's calling as Azure DevOps, this platform can be utilized for any type of language or any platform. So let's say you are building an application using Python, then you can use that. We have the built-in tools available for building and Python-based application. So regardless of the tools or language the development team is using for building your solution, you can use this platform. And you can use the same platform for building and deploying the solution to on-premise or any cloud, whether it is in Azure, Amazon, or Google. And we have fully support for any type of container-based workload. So nowadays, many of the cloud native applications are going in that model of application modernization. So if you want to build an application, and if you want to containerize that application, and if you want to manage the DevOps lifecycle of that containerized application, you can do that when using Azure DevOps service. And we have the built-in hosted agents available in Azure to support whether it is a Windows-based application or a Linux-based application, or even a MacBook-based application as well. So regardless of the platform of your application that you're building, you can use the tools available in Azure to make your CI/CD pipeline. So these are the different pillars. So the next few slides, we will go through some of the core pillars of the Azure DevOps a little more in detail. So you can see that, again, we don't have a demo to show you the details, but you can look at the screenshot on the right side. So Azure board, if you log into the portal, this is a place that you will be managing your project. You will be creating the features that you need to be implemented on your solution or a product, and then you will be assigning the task and backlog to the individuals. You will be tracking their progress, and you will be conducting the Scrum meetings. So we have the built-in Kanban board available. So you can use this one for a sprint ready meetings. You can just even move the task. So for example, if I'm a developer working on a project and the sprint master, he's going through a meeting and looking at all the tasks that I'm working on. And based out of the stage of the task, he can move around the task using the Kanban board. And the project insights is what you'll be getting a complete details about where the project stands today and how many iterations need to be done. And so all the management perspective of your project and the task you can manage using Azure boards. So one of the beauties about Azure DevOps is that it is enabling this DevOps lifecycle, which means we are bridging all of this stuff what you can see here in any of your pipeline till it reaches to the production environment and monitoring. Means, for example, if I develop an application and I deploy that application using a service, for example, Application Insights is one of the monitoring service available in Azure. And let's say in production there is an issue happen, it can create an work item as a bug, and it can create that one inside the board, and we can assign that one to someone. So you can see that it is connected deeply between all of this different life cycle that we have seen before in a DevOps. The pipeline. So pipeline is another one of the key feature that we should use for that continuous delivery of value concept. So let's say if I'm working on a particular application, there are 5 to 10 different developers working on the application, and whenever each developer commit or save the changes, we should need to make sure that that particular code is ready to deploy into a upper environment. So that is called the continuous integration. So whenever developers work on a particular code, and as soon as they check in the code, it should be ready to deploy. So we have the hosted build agents available for that, regardless of any application. Again, you can see that we have cloud hosted pipelines available for Linux, Windows, and Mac OS. You can also bring your own agent. So for example, let's say I have an application that I want to build that one in my company, in my infrastructure, but I want to manage that particular pipeline using Azure DevOps service. You can do that. We have the details available to download our agents and to manage this one using Azure DevOps pipeline. You can use any language, any platform, or any cloud, Azure, AWS, or Google. You can use that, and then you can use Azure DevOps service using the pipeline to build that particular application in a continuous integrated and continuous deployment fashion. And this pipeline itself, it is customizable. You can see number of open source based pipelines. You can find it from the GitHub. And we have first class support available for containers and Kubernetes. You can directly build the application and deploy into a Kubernetes environment or a container orchestrator directly from Azure DevOps. And it's a best-in-class open source based enable service. So you can also customize and you can bring your own services as well. And most of the pipelines that even we create are kind of an open source model, so you can further extend if you need to add more functionalities on that. So pipelines are directly connected to, if you want to implement the continuous integration and continuously deploy that one into multiple environments. It could be a test environment or a pre-production or even a production environment. And you can completely automate that process. So Harshal explained about the infrastructure as a code in an automated fashion. So you have to think about, if you want to automate everything, even the application that you are going to deploy into an infrastructure, you have to think about automating that infrastructure deployment as well. So for example, if my application is deploying into a web server, I need to make sure that the web server should be there as part of the pipeline before I deploy my web app. So So you can do all this kind of automation using CI/CD pipeline using Azure Pipeline Service. And Azure Repos, this is nothing but a source code repository. So we have unlimited number of private repos available, and it is supporting both the Git and Team Foundation version control system. So if you are using any Git-based source code repo today, you as a developer, you will not be seeing any much difference for connecting from your existing model into, if you're moving to Azure Repos, there won't be any difference because you are using the same Git commands or the tools built on top of that to work with the repo. Some of the key capabilities are, some common scenario is that pull review request or a pull request model. So that means like when we are working as a development team, when I make any changes to a particular code, I need to make sure that my peers review that and approve that one before I push that one into a specific branch. That will kick off, for example, a continuous integration pipeline. So if I need to achieve that one, again, this pull review request and approval, that model works well. So we have a deeply integrated that. There is a screenshot you can see on the right side. And you can see all these details are available as for primarily for the collaboration and for history tracking. All these details you can come and have a look into that. And we have the semantic code search feature enabled. So if you're searching for a code aware details, for example, class or a function or anything related to the code, we have that semantic code search capability available as well to do any kind of administration from the UI perspective. And test plans, again, this is another core capability. When you implement any application, you need to make sure that your application features are fully tested as per the use case scenarios. And also we need to make sure that that particular feature can scale when it depends upon the number of requests or the number of end users expands. We need to make sure that the application itself can handle the load. So if you want to make that any kind of a test plans for your application, you can create and manage that one using Azure Test Plan Service. And you can also use this same test plan to test your application in on-premise or whether it is in any cloud. It could be a web or a desktop application. You can do that one using Azure Test Plan. Another key capabilities are we have these test agents available across the globe in Azure Data Center. So if we are building an application and that application's end users could be in anywhere in the world. So if you want to simulate the performance, you can simulate that end user traffic from, for example, Singapore versus Europe versus North America. So you can do that from our hosted agents available in the Microsoft Cloud using the test plan service. So this is another core capability, and you can see that all of these details available in a single dashboard. How is the test plan executed? Are there any success, failure? All these details you can track in one place. So you can think about, again, from a Microsoft standpoint, we are providing a tool to support you on your DevOps journey to make sure that that particular concept of you making the union of people, process, and products. And this will allow you to collaborate in the same place. And whether you are a developer or a project manager or a tester or an infrastructure person, if you all are part of the same team and if you are working towards the same goal, you can come into the same tool and you can have a visibility of what exactly happening on your solution. And Azure Artifacts is one of the last component of Azure DevOps. It's primarily used for managing all of your application-related components. It could be a NuGet package manager, or it could be a Maven component. So anything you want to use for your application build lifecycle, then you can store that one in our artifacts. And then this artifacts is directly linked with Azure Pipeline, which is nothing but the continuous integration and continuous deployment pipeline. So you can use that one by hosting all of your necessary packages that would be helpful for your build lifecycle. Yeah, so that's all about Azure DevOps service. Again, it's a fully managed service to help your DevOps lifecycle easier. And this service is available, and it's a GA now. You can it's a free service. You can start with free, so you can create an account and you can easily onboard the users into that. So that's all about the Azure DevOps service. Harshal, coming back to you.
Sure. Thanks, Soumya. So, yeah. So finally, for the key takeaways, I'd like to conclude saying that for DevOps, there are many paths to success. However, there are even more paths for failures. And organizations like Microsoft, which have reached to the highest level of DevOps, they didn't reach it by accident, but they have a systematic and a planned approach. And healthcare DevOps success, or the DevOps success for any organization, as Soumya mentioned, it's a union of people, process, and product or technology. So the key takeaways from today's webinar are the collaboration for people are collaboration between software and ops team. That's very important. Team members which are working on multiple projects and applications would result in skill adoptions, which in turn helps in employee retention. Next, we'll go to the process, which is reduce bureaucratic process and red tapes. Do this by establishing governance and oversight. Make automated information security practices and healthcare compliances. And finally, in the technology section, reduce complexity via standardization. Make sure that the process of standardization is not hindering innovation. Hence, have steps, methodology for adding new technology or updating a technology. With this, I'd like to conclude the webinar. Yeah, thanks.
Thank you. Now we want to open it up to the audience for questions. As a reminder, please use the questions tab on the GoToWebinar console. Our first question, can you talk a little bit about what the best way to implement DevOps in a legacy application is?
Yeah, so for the purpose of this, for the response of this, I'll restrict it to the DevOps, because when it comes to a legacy application, there are multiple ways of architecting, like refactoring, re-architecting, redesigning, and rewriting. But the thumb rule here would be to draw the architecture for with all applications, define subsystems. I'm getting an echo, Laurie.
I'm sorry,
Hello?
I'm
Yeah,
not sure why that's happening. I am muted. So Mayan, are you muted?
Okay.
Yeah, I just muting now.
Okay.
Thanks. So one of the better practice would be to divide the overall application into smaller components and subcomponents. Define the ownership for a project team and make them responsible for quality gates. Have build acceptance test, which is a subset of automated test cases defined for these components. Defined using service virtualization. Take green builds from these components and have automated regression test runs, and then try to integrate that with the bigger systems. So that's how we would suggest. Soumya, you have any inputs or thoughts on this?
Yeah, saying again, it's all depends upon the life cycle and how we need to achieve that one throughout the life cycle. So that will be directly mapped into that DevOps model. Yep.
Okay, the next question. Can you talk a little bit about how to implement DevOps for databases?
That's a good question, because database deployments is always plagued with challenges. There are multiple challenges which come here. How do you persist data during upgrades? How do you load static data and test data? And finally, database is not just schema plus data. It is a lot of things. They're like their jobs, user roles, etc. So there are multiple tools for automating. In the market, there are multiple tools for automating DB deployments. There is Liquibase, Dactyl, Threadgate, which is specifically for Microsoft Stack, DB Maestro. But if there are mechanisms wherein you can use, if you are typically from a Microsoft Stack, you can use Entity Framework, and you can have command line commands to do migrations and SDD tools as well on that. So there are ways, but make sure that there is a command line process wherein the database upgrades are updated before any other applications and all. So there will be challenges, but I'm sure there are multiple applications and processes which will help you get over it.
All right, that was our last question. So that concludes our webinar. Thank you everyone for joining us today, and thank you Harshal and Somayan for an informative presentation. Watch your email for a link to the recording of today's webinar as well as a PDF version of the PowerPoint presentation. We look forward to seeing you at our next HIS Talk webinar, and I hope everyone enjoys the rest of their day.
Thank you, everyone.
Thank you very much.